Okay, so 11.2 is called series. And here's a definition of a series. It's not what you might think of if you just hear series in everyday conversation, which is something I didn't realize till a few years ago. Here's a definition of series. And you can say series, you can say infinite series. They're the same thing in this chapter. So I'll write a little sentence here. An infinite series, a sentence for the definition. An infinite series is the sum of the terms in an infinite sequence. So when we say series, we're talking about adding up the terms in a sequence. I don't really like I use the word sum there, but it's too late, right? So we are talking about adding the terms of a sequence. And a big part of this chapter is looking at something like that and determining if the sum converges or diverges. I need a little bit of notation. I want you to make sure you're familiar with this. The notation. This notation is the summation notation. And this is not going to be an infinite sum right now, but I want you to be familiar with this. So here's an example. The sum, that's what we say in math, the sum, this Greek letter sigma stands for sum or added up. So I'm going to start with n has a value of 5 and it goes to 9. And this is 6n plus 3 for the expression. So in case you've not seen this notation before, I want to show you an example or two. This means add it up, start with n equals 5, 6 times 5 plus 3, plus you go up by one integer each time. Then you plug in 6 times 6 plus 3, and then we'll go up to 7, 6 times 7 plus 3, and then plug in 8, 6 times 8 plus 3, and then plug in the 9, and this number at the top tells you what you're going to stop with. 6 times 9 plus 3. And then we can work that out. So 6 times 5 plus 3, that's 30 plus 3, that's 33. 6 times 6, 36. 36 plus 3 is 39. 6 times 7 is 42. 42 plus 3 is 45. 6 times 8 plus 3 is 51. And 6 times 9 plus 3 is 57. And if you take out your calculator and add this up, you should get 225. So, summation notation. You're going to see a lot of this in this chapter.